So, hi all, let's look into the Bayes theorem. So, Bayes theorem is most fundamental theorem which everybody should know before jumping into the machine learning era. Let's look into this simple problem to understand Bayes theorem. Here, we are having two different bags, namely bag 1 and bag 2. In the bag 1, we are having 5 blue balls and 4 red balls, whereas in bag 2, we are having 3 blue balls and 8 red balls. Okay, so let us ask this question, like, given that you are drawing a red ball, what is the probability that the bag is from bag 1? Okay? So to basically understand this kind of questions, let us recognize that what all are the events present here. Okay, so events. So basically here two types of events present. First one is, it is a event of bag. Okay, so second will be the event of ball. Okay, so in the event of bags, so let us consider bag is my random variable. Okay, so here random variables first one is bags, second one is balls. Okay, so bags can take two different things. First one is bag 1, bag 2, similarly balls, that is blue and red. So now let's draw a Venn diagram. So this is basically two different events. First one is like bags equal to bag 1, second one is balls equal to red. Okay, so these are two events. So this is what we call the common area. So this is like bags equal to bag 1 intersection balls equal to red. Okay, so this particular area is called, maybe you can say, set intersection, and in probability we are having another term that is called joint probability, joint probability distribution, you can say. So joint probability distribution. So like in the joint probability distribution, we are having two different events where they are occurring simultaneously. Okay, so let us calculate the conditional probabilities. Okay, so here we are having two different events, so accordingly we can have two different conditional probabilities. So first one is probability that bags equal to bag 1 given balls equal to red. This is one kind of conditional probability, and second one will be probability of balls equal to red given bags equal to bag 1. Okay. So if we look into this Venn diagram, so how to compute this one? Okay, so probability of bags equal to bag 1 given balls equal to red. So to compute this kind of probability, conditional probability, we will have basically probability of bags equal to bag 1 and balls equal to red divided by probability of balls equal to red. Okay, so what this is actually, so this is where the balls equal to red event is present. Okay, this is the region. Okay, so this is the entire region where we will have balls equal to red. So out of them, this is the conditional, this is the joint thing where we will have both balls equal to red and bags equal to bag 1. Okay, so what is the probability that the bags equal to bag 1 given balls equal to red? This is one kind of formulation. Okay, similarly, if we write the second one, so it is same probability of bags equal to bag 1 and probability and the balls equal to red divided by probability that bags equal to bag 1. Okay, this is the basically symmetrical type of setup. Okay, so the way how I computed one particular condition is similar. It is exactly similar the way I need to calculate the another conditional event. Okay, so this is like the computation of conditional probability. Okay, so now let's look into these two situations. Okay, so in the first, let's look into the second situation first. Okay, so what is the probability where balls equal to red given bags equal to bag 1? So you are asked to get the probability of what? Drawing a red ball given the bag is bag 1. Okay, so it is like quite feasible to compute. This particular thing is feasible to easy to compute. Why? Because yeah, you will be given one bag and you can randomly check in that bag like how many are basically red balls, and you can get the probability of red ball out of it. Okay, but this particular thing is quite difficult to compute. Okay, so what it says basically, like you are randomly drawing a ball, say the ball is a red ball, and what is the probability that you have drawn it from the bag 1? Okay, but it is very hard to compute. It is the opposite kind of thing. Like when you will be given one bag, there you can compute what is the probability of red ball, whereas you have been given one red ball and you are asked to get the probability of the bag equal to bag 1. Okay, which is quite difficult. Okay, so here Bayes theorem comes into picture. Okay, so like Bayes theorem is quite simple. Okay, so what it says, so it is just playing with the joint probability distribution. So in the joint probability distribution, okay, joint probability distributions. So in the case of joint probability distribution, what will happen? So we will have probability of balls equal to red given bags equal to bag 1 multiplied by probability of bags equal to bag 1 is equal to probability of bags equal to bag 1 given balls equal to red given probability of balls equal to red. Okay. So now you can see that this particular thing is easy to compute and this particular thing is difficult to compute. If I arrange it, then I will get probability of bags given bag 1 given probability of bags equal to bag 1 given balls equal to red is equal to, you will have probability of balls equal to red given bags equal to bag 1 into probability of bags equal to bag 1 divided by probability of balls equal to red. This is the expression. So now in this expression we are saying this particular notation as the posterior probability. Okay, and this particular thing is called likelihood. This particular thing is called prior, and here this particular thing is called marginal. There are some probabilistic notations which we will see like why they are called so. Okay, so now like what you know, like you it is easy to compute that this particular thing. Probability of bags equal to bag, this is also easy to compute because it is something the prior thing, like you are having two bags, you already know that you are having two bags, so if they are equally likely, then it will be the probability of choosing one bag will be one half. So if they are equally likely, so probability of bags equal to bag 1, basically half. Okay, so now these things you can compute by practically you just choose bag 1 and you can count and you can get some sort of number. In our case we will be having, okay, in our case we will be having probability of ball equal to red. So we are having 4 red balls out of 9, right? So here we will have probability that red given bags equal to bag 1. Yes, I guess 4 out of 9, I guess. Right, 4 out of 9. So now let's see into this marginal thing. So what does it say? Like in this case, denominator, this looks into all possible bag events, all possible samples of bags. Okay, so what does it say? So probability of bag summation over all bag. This is what marginal means. So marginal means you are having one joint distribution and you are trying to strict over one particular outcome and try to see across the other event, all possible outcomes of other events. Okay, so here I will basically sum over all bag type of samples, provided I will only stick with the red balls. So that means how many red balls present in bag 1, how many red balls present in bag 2, and I will calculate like that. So in this case, you know, right, joint means what? Simply probability, it is summation over all bags. Probability that balls equal to red given bags equal to bag, I can say, okay, into probability bags equal to bag. I am marginalizing. Okay, so in that way, if I compute, then what I will get? So it is basically probability of balls equal to red given bag equal to bag 1 into probability of bags equal to bag 1 plus probability of balls equal to red. I am sticking towards red ball. Bags equal to, in this at this time I will be considering bag 2 into probability of bag 2. So here what you will get? So you know, right, probability, the first one you know, it is 4 by 9 into half plus what is the probability of it is 8 by 11 into half. Okay, so in this way you will have the marginal type of setup. Okay, so you just put all these formulas over here and you will get the what is the probability, your posterior probability, the probability of bag equal to bag 1 given balls equal to red. Okay, you will get if you put these numbers. Now question comes like why we guys are doing like that. Okay, so if I don't know like what is the application of this particular thing, then I should not use it. Okay, but believe me, this is the most important theorem, basically you can say most basic theorem in the domain of machine learning. So in the domain of machine learning, okay, let's jump into machine learning part. Machine learning, So you are basically given a sample. You will be given one sample. Sample means one instance. Okay, and you are asked that what is the probability that it is class equal to C1 given this sample equal to instance, whatever. Okay, so that means you will given one sample and you are asked that what is the probability that this sample belongs to class C1. Easy. So let us coin some new terms: hypothesis and evidence. Okay. So hypothesis is something like that, like you are hypothesizing something, like you are thinking with this. This shows your thoughts, like what are you thinking about this sample. Okay, so that means what, whenever I will give you one sample and I will say that there are 3 possible classes, so you will have some amount of thoughts about like which class this sample may go. Okay, so this particular thing is basically called hypothesis. And evidence is something like this sample, like you will be given one evidence. Okay, you will be given one evidence and you are asked that given that evidence what is your hypothesis basically. So in entire machine learning setup you will be asked this particular thing. So what is the hypothesis, probability of your hypothesis given this particular evidence? Okay, so simply you just apply Bayes theorem and you will have this kind of formula. Okay, so let's not write in this way, let's write in this way. Okay, so what it says, like simply it is the probability of hypothesis multiplied by probability of evidence given a hypothesis, okay, divided by what is the total probability of evidences. Okay, so again if we look into it, this is called the marginal, this is called your prior, and this is called the likelihood. Okay. So why this particular thing is called likelihood? Okay, so what I mentioned before, like imagine that hypothesis is some kind of bags. Okay, this is the bag 1 and this is the bag 2 and this is the bag 3. Let us assume that you are having 3 different classes and samples are something scattered. Okay, discrete samples I am talking about. Okay. So this is your class 1 C1 and this is the class 2 and this is the class 3. Okay, so when I ask you that, let's say this is my x, sample x, so I will ask you what is the probability of class equal to C1 given the instances or evidence equal to x, then it is something like that, the probability of class equal to C1 multiplied by probability of evidence equal to x given class equal to C1 divided by your marginal. Okay, so this is called prior. So prior means what, you know 3 classes are there, and in this case you will have some sort of assumption that what is the probability of each class. That let's say you are having samples, by counting you can get some sort of notion like what is the probability of class 1. So let us assume that these 3 classes are equally likely. That means probability of class equal to C1 is kind of 1 by 3. Okay, shorted. Okay, again if the classes are not equally likely, then you can count, like you can count to establish what is the probability of class equal to C1. That's easy. Second thing what I was talking about, it is the likelihood, probability of evidence given x class equal to C1. Okay, so this thing also you can compute, right? So you are having 3 classes, so condition on class 1 means just stick into this particular class, and in that particular class just count what is the probability you are getting where evidence equal to x. that is easy. Again, you just consider that particular class C1 and just do some sort of counting and you can estimate its probability. Okay, so probability is kind of, probability value is kind of proportional to its frequency. You can say probabilities are normalized frequency, probability to normalize frequency. Okay, so you can estimate it. Okay, so likelihood means that how likely that evidence X is belonging to that particular class. So what is the probability that evidence X is going to that particular class? So here you just think that here the first event is like class, you have been given the class information already. Okay, from that you are trying to estimate the probability of evidence X. Okay, so in this way basically you can have some sort of idea about the likelihood of that particular evidence X. Okay, so now come into the marginal setup. So in the marginal setup, what you need to do, it is the sum of all classes of probability of class equal to, let's say, class into probability of evidence equal to X given class equal to all the class. So what does it mean? So okay, so you got likelihood, okay, but that particular likelihood you need to marginalize over all the class objects. Okay, so you got, okay, I get some sort of notion about the probability of evidence X present in class 1. Then what is the evidence X present in class 2? What is the evidence X present in class 3? Okay, let's sum up these all probabilities. You will get the marginal probability of occurring evidence X across classes. Okay, so you got the marginal and you got your likelihood. Okay, then to the likelihood you basically multiply its prior information, what I told, like, okay, so likelihood into prior is basically your joint distribution of your evidence X and your class C1. Okay, so you have some sort of notion about your joint distribution of class C1 and your evidence X, and you just marginalize that joint over all three classes. So in this way, like, you have some sort of notion like probability of class C1 given E equal to X is equal to, it is a joint of class equal to C1 E equal to X divided by the marginal all classes, the probability of class comma E equal to X. Okay, in this way basically you will have some sort of estimation. Okay, so randomly I will give you some sample, then you can say that okay, this sample belongs to class C1. Okay, it is quite intuitive. What I mean to say is basically when you are going through all these classes, then you will have some sort of idea that if that event X is occurring many times in class C1 then that of class C2 and class C3, then you can give some estimation that then for the given evidence X, the class equal to C1 is some number, some probabilistic value. Okay, in similar way you need to calculate probability of class C2 given E equal to X, probability of class C3 given E equal to X. Okay, then you just compare like what is the highest number or highest probability value among these three, and that will determine that which class the evidence X will go. Okay, so this is the simple funda of using Bayes theorem in the machine learning. Okay, so the important part is what is likelihood. So likelihood basically what I told, probability of evidence given hypothesis. Given hypothesis, what is the evidence? This is the likelihood. So what is prior? So prior is basically probability of your hypothesis. So this is prior, means you know there are 4 classes are present in your complete data set or data distribution. So if you think that these 4 classes are equally likely, then each of these class will have a probability of 1/4. If they are not equally likely, then you can just count and estimate some sort of probability out of it. Okay, then what is marginal? Okay, so marginal is basically summation over all hypotheses. It is the joint of E equal to small e, let's say. Okay, these are three important things which one should know. Then if you understand these three things, then you can easily compute the posterior probability, that is probability of hypothesis given one evidence, which is the goal of all classification models in the machine learning. Okay.